Hey guys, we're going to do Chapter 5 Rocks, Section 5 Metamorphic Rocks. Please make sure that you use this as your title here on each paper so that you don't lose track of where you are as you go through your notes. Today's objectives. Under what conditions do metamorphic rocks form? How do geologists classify metamorphic rocks? And how are metamorphic rocks used? You will need to be able to answer these three questions by the end of the notes and have them answered in your notes. So, metamorphic rocks. Heat and pressure deep beneath Earth's surface can change any rock into a metamorphic rock. So that means a sedimentary rock can actually become a metamorphic rock. Igneous rock can become a metamorphic rock. Metamorphic rock become a different type of metamorphic rock because of this heat and pressure. It will change, it will subduct it. So we typically see this at the mid-ocean trench, deep ocean trench, sorry, where this subduction occurs. It doesn't just happen there though. Texture, appearance, crystal structure, and mineral content change, and that's what causes it to become a metamorphic rock. Now, metamorphic rock can form out of igneous, sedimentary, or other metamorphic rocks, as I stated previously. So how this happens is because of the collision between Earth's plates. It pushes the rock back down towards the heat of the mantle. The whole thing with the continental crust and oceanic crust, and which one's more dense, and it's subduction when they crash. That's when we are going to have this creation of metamorphic rock. Now, it doesn't have to subduct all the way back down in the mantle, because what happens, as we've discussed before, you've seen how the mantle starts to subduct back down. That until that layer is fully subducted back down, melts, it's reheated and recrystallized, and new minerals are added to it, and all that pressure that's acting on that plate actually is changing it and causing those rocks to change and become a new rock. So, deeper rock is buried, the greater the pressure. Sorry. Woo! Sorry. So, as it gets deeper and deeper, there's more pressure and more pressure. This increase in pressure is what is changing the rocks. What's going on? There it goes. Sorry. So, metamorphic rocks form when heat or pressure change pre-existing rocks. Metamorphism is the process of forming metamorphic rocks. So here you have a great amount of pressure. Pressure is increasing as, sorry, let me go back. Pressure is increasing and causing this morphism to change, okay? So that extreme heat from the mantle inside heats up that lithospheric plate and melts it and changes the rock at that surface there. The formation of metamorphic rocks. There's a recrystallization. This is the process of increasing the size of the mineral crystal's class and or changing the mineral composition without melting. It's just heating it up and adding pressure, so it changes its shape, it changes its composition. It doesn't have to melt. With metamorphic rock, it's not going to melt. It's just heated up and pressurized. It's like taking a marshmallow, putting it in the microwave, heating it up. It becomes bigger, it becomes fluffier, and then all of a sudden it hardens back and it's changed a little bit. So high heat and pressure allows atoms to rearrange. So here's what's happening. You originally have image A here. What's going on is, let me move, oh, I can't move it, sorry. I'm hoping that my picture's not covering this. If it is, I apologize. What's happening is originally you have this image A here. This is how the minerals are aligned, you could say. The heat and pressure causes the minerals inside of the rock to realign. So instead of having this mixed up look, they all of a sudden become straight in rows. So metamorphic rocks can sometimes look like sedimentary rocks because they will have this band-like structure to it, where you can see all the minerals lined up. There's types of metamorphism. Contact metamorphism is caused by contact with extreme heat. So lava, magma, or hot fluids will alter the rock. So sometimes that heat is from that magma or lava. So there's no foliation, okay? So contact metamorphism is when it subducts so far down that it's right here above this magma chamber. It's not melted, okay? It's just being extremely heated up by this magma chamber that you see here, okay? There's all this pressure. You can't forget there's pressure there because look how far down it is below that volcanic mountain. Okay, so what happens is all this pressure happens, and when it erupts, it can actually shoot these rocks out of the volcano. So when extreme heat is added to a quartz sandstone, you get quartzite, okay? So you have quartz sandstone, which is this right here, between heat and pressure, okay? You're going to get this quartz stone. For example here, you have, sorry. You have limestone. Limestone is a sedimentary rock, as you learned the night before, and you're going to get this really pretty shiny white looking marble. So here you have two different rocks that are now a new rock because they've been pressurized and heated. So here you have a really neat piece of rock here. So you see the different layers. A thick body of diorite was injected between layers of limestone of Helena Formation in northern Montana. So this is in Montana. You can see the different layers. The great heat of the intrusion baked the limestone above and into the marble. So what happened is you have these two limestone layers here, all right? And because of the heat, okay, diorite is igneous. What happened is the pressure from above and the heat from the diorite caused marble to form in between these layers because you have an intrusive layer here of diorite. You're going to learn when we talk about volcanoes how we can have these different eruptions within the crust. So here, because of the amount of pressure on the limestone, the diorite being injected in the middle here, that heat has caused the marble to be created. So it melted that limestone, and actually we have three different rocks in one mountain. Kind of cool. Types of metamorphism. You have granite becomes gneiss, okay? This is considered regional metamorphism. It occurs over wide regions when rocks are exposed to extreme heat and pressure, okay? So it occurs over wide regions. So rocks are exposed. This picture here, that's what we're talking about here. That's regional metamorphism. You have foliated rocks, folded rocks, and faulted rocks. Foliated rocks mean that you have these like bands, these stripes in them that you can see. So they kind of look like sedimentary rocks. Folded rocks is when you have these folds in it. Okay, see how it folds here? That's also foliation, but it's folded. And faulted rocks. These are going to occur at fault lines. So this occurs between collisions between Earth's plates, kind of like Yachty and someone trying to take home plate. They're going to collide with Yachty or Molina, and you're going to have a crash, and someone's going to subduct and go down. So collisions between Earth's plates can be pushed in the rock down towards the heat of the mantle. This is how we have these metamorphic rocks being created, is that process of subduction is involved in the creation of metamorphic rocks. So what happens is the convergence of plates cause deformation, uplift, and regional metamorphism. So as these plates collide, they're going to run into each other. Okay, and you're asking, how does that happen? Well, remember continental drift theory. So here that theory comes back. So if this theory holds true, here's some more evidence to prove it. As these plates collide, it's going to cause this heated layer because we talked about convection currents and how convection currents heat up parts of the lithospheric plate. And as it does that, these rocks, when they're pushed, they get squeezed together. And as they get squeezed together and heated, we're changing that rock. So if it was originally igneous, let's say it was granite, now all of a sudden it's becoming gneiss, okay, because it's getting heated and pushed and melted. So warped, distorted layers. So this is why you see these crazy bands and a lot of metamorphic rocks. So the real big difference between sedimentary rocks and metamorphic rocks and their bands is metamorphic rocks will tend to have like wavy lines to it in their foliation. So before deformation, horizontal bedded sediments, they're usually straight across. This would be like a sedimentary rock. After it, it becomes these wavy bands. I highly recommend you drawing this example into your notes so that you have a better understanding and a good reference to this. Here are some folded rocks. Okay, so folded rocks, this is actually in Maryland. Here is metamorphic rocks. You can see where the continents were pushed and caused the rocks to change and squeeze it like an accordion. So I would draw this. You have the deeper rock is buried, the greater the pressure on the rock. So metamorphic rock is being created because there's extreme amount of pressure, extreme amount of heat coming up. And so the mixture between the two, they're pushing up on each other and creating this melting and pressurized system that's changing the rock's shape. I cannot emphasize this enough. So under high temperature and pressure, many times greater than the surface, minerals in a rock can be changed into other minerals. So types of metamorphic rocks, okay? We have foliated, they have layers of mineral crystals. I would draw these, by the way. This occurs when pressure aligns minerals into layers, okay? So once again, you have all of these unorganized minerals, and when they become foliated, they become straight lines. So non-foliated rocks are not layered. Rocks were subjected to directional pressure, and or minerals are not flat. So this would be quartzite and marble, sorry. So you can't see any bands, you can't see any directional pressure. They're just basically reheated and pressurized a little bit. The pressure from above is acting on them, but they're more pressurized and not pressurized, heated, so it's going to change it. So there's not this banded look to it. Key identifying features of metamorphic rocks. So here's how you can really identify a metamorphic rock. The foliations, bent and distorted layers. See these layers here, how they're distorted? Yes, you have foliation, but it's also distorted. Garnet is another key identifier. Dark red color. You're only going to have that in a metamorphic rock because it gets subducted back down, it gets mixed with some new minerals, and it's going to create these garnet crystals. Mica, if it's flat, flaky, and shiny, it's going to be a metamorphic rock. So if it breaks off really easily, that's a key identifier for it to be a metamorphic rock. So let's do a couple examples here. So here's the graph you're going to see again for metamorphic rocks. You have the foliation, whether or not the mineral alignment is, if it's banded, non-foliated. Type of metamorphism, is it regional, is it contact, composition. Here's some comments, the rock name, and the symbol of the crystals. So this one's got a lot of information for you to look at. So which metamorphic rock is non-foliated and composed of calcite? Take a minute, pause it, look at it, and see what you can figure out. You should have figured out that it's non-foliated, and it is right here. We have marble. Okay, I don't know if you can see if my picture's covering it, but metamorphism of limestone, regional or contact, calcite, and dolomite. Okay, so the key word is composed of calcite. This is the only one that really shows that it's being composed of calcite, and it's fine to coarse grain and grain size. Let's try another one. Which metamorphic rock is foliated and consists of only mica? So your composition is mica, and it only is composed of mica. Take a moment, pause it, look at the graph. You should have found that it is up in the top. It's foliated. It's fine. Main composition is the only one that consists of mica, so you should have gotten slate. So, objectives. You need to answer these questions in your notebook. Make sure you can answer them all. If you cannot, you need to come see me and we'll talk further about how I can help you better understand metamorphic rocks. Have a great night.